quadratic function y is equal to x squared plus 2x minus 3's domain is x can be either less than equal to 2 or greater or equal to negative 3. And this is the domain of our function. We need to solve for the range of this quadratic function. Before we go any further, let's think about the two types of the quadratic function. And for all kinds of the types of the quadratic function, they're all defined by the a, which will going to be the leading coefficient. So for the first case, is a case when the a, which will going to be our leading coefficient, is greater than 0, which means when the leading coefficient of a quadratic function is a positive value, then the graph of the quadratic function will open or go upward. And when the quadratic function's graph goes upward, for example, it will look something like this that keeps going toward upward and never ends, which means it will going to contain a specific one point right over here. And this point will going to be the minimum point of our quadratic function, which we also call it as lowest point of the quadratic function. And this occurs when the a value, which will going to be the leading coefficient, is negative. And for the second one is when the a value is less than 0, which means when the a value is equal to negative. When the a value is equal to negative, the graph of the quadratic functions will go or open downward. When the graph goes downward, it will look something like this. That keeps going downward, and it will going to contain one specific point, which can be maximum point, or we can also call it as a highest point on the graph. And if you think about the definition of a vertex of the quadratic function, vertex stands for the addition of our two number possibilities of our either minimum point or the maximum point. So if we add these two number possibilities, we call it our vertex of a quadratic functions, and they're all defined by these cases of leading coefficient, which we usually call it or notate it as a. We draw our quadratic functions graph, which we're going to be y is equal to x squared plus 2x minus 3. So since we knew that our leading coefficient, so if you write our quadratic function down, which is y is equal to x squared plus 2x minus 3, and our a value is equal to 1, which means our a value is equal to positive. That means the graph will go upward. So if you write it down, the graph of this function will go upward, and then it will going to contain only one lowest point, which will going to be the minimum vertex. So at first we need to find the vertex of the function, because vertex is the most important thing in the quadratic function. And when it comes to solving for the vertex of the function, we know that y is equal to x squared plus 2x minus 3 will going to be the standard form. And the standard form means it is in the ascending order, where there is x squared term, then we have x term, and we have our constant. This is what the standard form is. And if you think about the good point or the pros of this standard form, it is easy to find the y-intercept. But in order to solve for the vertex of the function, we have to convert specific forms into um, into a vertex form, which we usually call it as a perfect square. We're completing the square. But since we learned in the last video, if you think about converting this into a vertex form, it takes too many times, or it takes long. So for the efficiency, we applied one formula for it, and it is when the vertex is formed by x comma y. You just try and find the value of the x value. The reason why we don't really have to memorize the y value formula is because we know that x is the input of our function, and the y will going to be our output of our function. Which means when you input a value, which means only thing we need to find is the x value. If we input it to our original equation, we're going to form a specific output, which will going to be y value. So if you remind yourself about the formula, it was negative b over 2a. Let's think about its functions or these statements. So in the numerator, there is a b. For the b, let's write our formula later. So our formula was negative b over 2a. And we're talking about the b terms, which is located in the numerator. So if you think about the case of the b, it will going to be the coefficient. So b is equal to the coefficient of the first power term. Or we can also call it as a variable. If you think about the definition of the coefficient, coefficient shows just a integer or just a number that is isolated like a constant without any variables. But the coefficient will going to be the number that is included or that includes the variables. And this is what the coefficient means in the quadratic function. So b is a coefficient of the first power variables, and the variables in this case were going to be x, which changes depends on the situations. And if you think about the a term, a is a leading coefficient. And also a is the same thing that we use to prove our types of our function, where it is used to define the types of the quadratic function. So a is our leading coefficient, which means it is a coefficient of the highest power terms. So if we can actually realize, and we can input our values and solve for it. So if you write our quadratic functions coordinate down, it will going to be, instead of x, we can write our formula, and we have our output of our function, which is y. So the b term will going to become the first power variable, and our first power variable will going to be the x terms, and our coefficient will going to be 2, which will going to be our integer. And if you think about 2 times a value, the a is the leading coefficient, which will going to be just 1. So we can simplify our expressions. 2 and 2 want to cancel out as 1, we get negative 1. So this will going to be our x, coordinate of our vertex. So it will going to be -1, comma y, and for solving for the y, all you have to do is we need to input our x to our original function back. And our original function was y is equal to x squared plus 2x minus 3. So if you input -1 to every single x terms, we're going to get y is equal to 1 minus 2 minus 3, which we're going to end up being -4. So we can figure out that our vertex of our quadratic function, which will going to be the minimum point or the lowest point in our quadratic function, will going to be -1, comma, -4. So if you drew a approximation of the quadratic function's graph, we don't have to draw the x and the y-axis. All you have to draw is we need to draw the basis of our quadratic functions. So we could figure out that our quadratic function is open upward, and this is our y is equal to x squared, and then plus 2x minus 3. Since we need that our leading coefficient is positive, so it opens upward. And for our vertex, we're going to be located, which we're going to be our minimum point. And then this was coordinate. The coordinate of this vertex was -1, comma, -4. But there is a domain of our function that they gave us. And they were charged and they tell us to find the range. And let's think about definitions of both of the terms. And for the domain at first, so there is domain and there is a range. The domain shows a particular range. Range is same thing with distance of the x values on the coordinate. So on the coordinate. And for the range, it shows the range, which will going to be the distance. This range and this range are clearly different. And the range of the function will going to be there is the distance of y values on the coordinate. So this is what the domain and the range is. So we can apply our definition of domain and the range to our original function. So if you write our quadratic function down again, y is equal to x squared plus 2x minus 3. And they gave us the domain of the function. So if you write it down, it will going to be -3 is less or equal to x. And the x value is less or equal to 2. So this is our domain of our function, which means it shows our x values range, which included our x value. So we're only caring about the function in this limitation. And it can mean it in this way. For our original quadratic function, it keeps going upward, which will going to be infinite. It will infinitely goes up. But then there is our new limitation, where we need to think about x's range. Our x's range is -3 and then 2. But our x value includes both of these numbers. So we can include these numbers to our function. So if you think about but we need to say that -3 and then 2 are the all x values. And -3, if this is -1, -3 will going to be somewhere right over here. So this will going to be -3. And for 2, 2 will going to be somewhere right over here. So basically -3 is here, and then 2 will going to be here. So if they gave us the domain, we're only caring about the function beside our domains, which means we're only caring about the terms that I'm coloring right now. So that means we don't have to care about the other terms. We're only caring about in our limitation. So first, we need to think about -3. -3 right over here, it includes. The 2 is right over here, it also includes. So let's think about the new vertex of these functions. And our new function means our original is not our original function, the function that we made. And that means you are going to contain either the maximum point or the minimum point. The reason is because it has the limitation. So our maximum point will going to be the highest point when the x value is equal to 2. So when the x value is equal to 2, we can input our values as tutor x values, which will going to give us y is equal to 4 plus 4 minus 3. It will going to be positive 7. And for the minimum point, it will going to be the lowest point of our quadratic function, which will going to be the case, which will going to be our original function. So we can write -1 comma -4. So we found either maximum and the minimum point of our new function, but our question is, or our ultimate goal is find the range of the function. And for the range, either it shows the distance of the y values on the coordinate plane, which means these are the y values 7 and the -4, and the x value and the y values, which are our algebra function, should be between them. So this will going to be our range of our function. All we did is we found the vertex of the function. There was our two y terms. And the only reason why we could find the range in our quadratic function is because it had a limitation in our original function. So our ultimate goal was to solve for the range of the function, which our answer was going to be -4, y, and then 7.